Thank you. So, thank you everyone for giving me this opportunity. So, basically, I'm Dr. Tuhin Sahu. So, I'm from Exide Energy Solutions Limited, India. I thank you all for giving me this opportunity to represent my organizations and our vision on lithium, solid state batteries, and also myself. So basically, I'm like I did my PhD from Sydney on lithium sulfur batteries, and then I was at University of Texas Austin for a year to work on lithium sulfur and sodium sulfur batteries. I did some work on sodium ion and lithium ion bit solid state as well. So and then I moved into here Exide Energies. So first, I would like to talk about my organizations, a very brief introduction and what we are and what we're looking for. So this slide talk about the lead acid battery. Basically, we are 100% subsidiary of Exide Industries. So it's a very well-known brand in India for lead acid battery. We have 75 years of legacy, making lead acid batteries and having facility all over the India and a goodwill to develop our product with time. And we are the one company that have made lead acid battery for two-wheeler, three-wheeler, four-wheeler, and also for submarine in Southeast Asia. This is the only company that makes lead acid battery for submarine uses. So this is who we are. So basically, we are Exide Energy Solutions Limited. So it's a new venture from Exide Industries on lithium-ion battery because as of now we don't have any gigafactory in India for lithium battery making. So we're gonna put a 6 gigawatt hour plant in our phase one in the southern part of India. And later on, we are also planning to have expansion of another 6 gigawatt hour by 2030, and we're gonna make LFP and NCM batteries basically, and some carbon composites, and also gonna have a strong R&D as well, where we are looking for solid state batteries and some advanced cathode material that can circumvent the issues with LFP chemistry as well. So it's a very generic one. These slides talk about why we need electrolytes. So it's about the helping movement of lithium ion from one side to another, and there are a lot of electrochemistry and chemical reactions involved in these steps. The hopping mechanism, solvation, desolvation, the donor numbers, and everything, and the addition of ACI layer to have stable interface. And you need ACI because you don't want your electrolyte, your electrode material to get exposed to the electrolytes, so that for the electrolyte degradation happen, irreversible coulombic efficiency loss. So those are the reason basically why you need a salt, a solvent, and additives particularly. And solvent commercially we use ECPC, DMC, DEC, and you can see this table where you can see their physical properties. Basically, that is responsible for the lithium ion conduction and the flash point. Particularly, I would say some of the electrolytes they are having EMC composite, and EMC basically added for the low temperature performance because of its low viscosity. But you can see its flash point is very low, which means that in presence of fire, it even catch fire. It takes a flame. It can take fire actually. So which is a compromising the safety of batteries, and even the other part like EC and uh, it solid tends to solidify at room temperature. So increasing viscosity that we see in LFP batteries basically, at low temperature its performance low. Because slow ionic diffusion is the reason, and again the another reason is the viscosity increase in the electrolyte part. So the problem is with the safety issues and the heat generation. If there is any heat generation, so then there is chance of this thermal this thermal runaway that is happen. Shrinkage of your separator at 120, even if you have alumina coated. So at 130 degree around it starts shrinkaging, and then you have micro short circuits, and all these electrolytes they are flammable. And apart from that, the material degradation, that is the another part. So these are the reason why we need solid state battery. So this data chart it shows the energy density value. I mean, even though what earlier, the presenter they mentioned that the energy density is the main reason, and safety wise there is a huge energy formation that could happen once you use lithium metal.